Hello, my name is Timo Tokola and I am giving the lecture related to EU expertise in GIS and remote sensing technologies. So we will have an overview about the skills and competencies needed for graduates in our forestry GIS and remote sensing fields. So we will cover three subjects. So large area forest inventory issues are the one, and then biometric modeling, connecting also detailed forest inventory and remote sensing, and then GIS issues. So the biometric models, national forest inventory and database planning are very important subjects, because in the principle our goal is to transport food from the field into the mill sites, and there is need to identify availability of forest resource. There is need to identify forest resources and industrial opportunities. So altogether every year we have more than 150,000 timber transactions, and we have really big logistic exercise here in Scandinavia and in Finland, especially in this case. So the forest resource data collection, it's partly done in national level, like in the left side image, and then management planning is procedures used to make the decisions, make the detailed digital maps, management plans. And then a third big activity is the forestry activity monitoring. What has taken place in the forest? So we like to record the delineation of harvesting stands. We like to see what are the changes. We like to report and update our databases. So there are principally three different big operational items which we are using here in Scandinavia. The NFI and management planning inventories are really the big things, and NFI, National Forest Inventory, it's organized through the National Research Institute, and it's covering the entire country. We have about 100 years history in this work, and also the satellite imageries are used in that work. Then the management planning organized by the forestry centers. It's delineating homogeneous stands, and it's nowadays mostly done with LiDAR-based technologies, although fieldworks are of course included. So very often we need to predict distributions. We are not only predicting some mean parameters, and that's really the current trend. We need to predict diameter distribution of different variables, because the size distribution of forest stands is nowadays requested by the companies, and all management people are interested about that. So the structure of our forest database is nowadays covering more and more different items, and of course we have different map data sets. The general structure includes different type of maps, field plots, different type of calculations, different type of reporting, and different type of internet map server services. So our students, they really need to have different perspective from mapping point of view, as well as forest inventory point of view, as well as IT technology point of view. So in case of the large area forest inventories, we of course use different type of sensors, remote sensing sensors, and we have done research from the different sensor resolutions, and very often the idea is just to reduce variance in our field data collection works, and we try to identify different type of forest, maybe clearly separate non-forest, and then the uncertainty is always there, and of course to uncertain areas we need to allocate some field work. Basic remote sensing datasets of course are all used, and the resolution depends of course on the purpose. Principally we teach the use of different materials, and of course if we train people we use very often two-phase sampling approach to predict how much images in the different or how much field work is needed for certain reliability level. And this multi-phase sampling scheme is more or less the common way of thinking. So we have full coverage of very rough resolution or medium resolution satellite data. Then we have always higher resolution imageries or lighter data. But always in addition to those we need to have good ground measurements, sometimes even very detailed field plots for the growth and other detailed data sets. Nowadays we have covered entire country with timber procurement maps, which are derived based on satellite imageries. So NFI, so for National Forest Inventory field plots are used to as a ground truth data, and these data sets are used by the private companies to check the availability of different raw materials. So there are different issues always related to large area monitoring, and one example is demonstrated here, that we really need to have representative field sample. So that's one key issue when we have different different conditions in the different part of our country. So there is always need to manage the methodologies related to calibration of different images. So radiometric calibration is very important skill what is needed in large areas. Topographic correction is also one skill, and how to process imageries for that. Then for burnt area reflectances we need to sometimes use when we this is not especially difficult, but it's one skill also needed nowadays. Maybe the biggest effort nowadays is done in the real detailed remote sensing and LiDAR technologies. We have different strategies, from the trees to stand data, where we sum trees and estimate small trees with biometric models, or directly to stands, and we use tree distribution. So we are developing methodologies to identify single trees, and how we also predict the parameters for unrecognized tree size categories. So the different segmentation techniques have been developed for single tree detection. So we detect trees and identify tree borders. But maybe the most operational is still the direct prediction of whole diameter distribution based on LiDAR metrics, and we directly predict then using go nearest neighbor or go most similar neighbor technologies used very often to predict the characteristics of forest stands. So we use these LiDAR point distributions in certain areas to predict the canopy characteristics, and directly the diameter model diameter classes of specific small areas. So we are calling this one as a area-based approach. So it's operational in Finland, covered everywhere nowadays, and also the species are separated, but also we have aerial photos from these areas. GIS, integrating everything, that's clearly one needed skill, and we have now so various needs. We have now different ways to deliver information. So the automation technology is now spreading. So we have different sensors in harvester machineries. We have different sensors in the mobile phones. Resolutions are varying quite a lot, and nowadays we are using more and more very detailed 1 meter grid, LiDAR grid, covering our forests. So in the end we have more than 100 parameters, different layers in our databases. This is one example about Forest Service database, where we have really huge set of different attributes. So, and in the end the companies are extracting operational plans. They are, when the harvesting exercise is done in the field, they are utilizing these operational maps in their works. So, but LiDAR data is also used directly, so in the management planning. So these LiDAR predictions are now printed in GIS user interfaces in very detailed form, and managers are utilizing those datasets as well. So distance is coming more and more into biometric models. So the spatial growth models are introduced, but not yet operational. But they are different alternatives for growth modeling also developing at the moment. Visibility is one thing. We have tools to demonstrate visibility in the different harvesting schemes. That's used mostly in the urban areas. Transportation cost. Energy wood is very sensitive for harvesting cost, so we like to compare different schemes. If we have energy mills, we like to have maps which is indicating how much harvesting costs are in the different part of our timber procurement area. So GIS system self, they are developing all the time. The map server concept is used to share the data. Companies are offering their own concepts, map server concepts for the forest owners, and these user interfaces are now tailored for non-professional users quite heavily. So also Forest Service, and there are other institutions who are sharing their information in the form of the electronic map in the internet, and that's very, very popular concept nowadays. And our students, they also need to understand and know how we are able to share our maps and our attributes through the map server concept. So, thank you very much. This was really quick overview over our teaching and our needs in this area. So, maybe as a last thing, I would say that all our students are also learning programming. So the Python programming and integration with different GIS and remote sensing tool is very important. We also like to utilize a lot of our language in our training. So those two skills are pretty much appreciated nowadays. So again, thanks for you, and all the best. Ciao.